In this video, we'll build our very own custom hook which will allow us to incorporate responsive features in a function component. So let's get to it. You've been exploring hooks, and by now you must have realized the incredible power and simplicity that they bring to your React application. The fact that function components, simple as they are, can be turbocharged with hooks has really changed the way we write React applications. But the real power of hooks lies in the fact that you can write and share your own hooks. Your very own hook could be a custom feature or service that your application uses, or it could be a feature that the entire React community might find useful. A custom-built hook allows you to share stateful logic with multiple components. React developers have frequently used techniques like higher-order components or components that implement render props to write features that can be shared across multiple components. But a custom hook is perhaps the best way to write shared and reusable logic. The only caveat being that hooks only work with function components, so if your project contains class components, you'll have to stick to higher order components or render props. So what exactly is a custom hook? A custom hook is a simple JavaScript function that begins with the word use. This is how React and the toolchain recognize the function as a hook. A custom hook can incorporate state, side effects, and other logic using standard React hooks. Finally, a custom hook exposes properties and methods that can be used to interact with and use the hook in your function components. To understand how a custom hook can be built, let's work through an example. As always, download and set up the project from the link given on the screen and fire up the development server. Our application here displays a login UI which has a cover image and a form. The style sheet for this project includes a vertical class which switches the rendering format for this UI to vertical to suit smaller screens. Now, usually you would handle something like this using media queries in your style sheet, but we'll build a custom hook instead. This has several advantages. For example, while viewing this UI on smaller screens, we want to be able to conditionally display the phone login component like so. We therefore need an interactive way to render this component only on smaller screens. So let's build a hook which will provide interactive breakpoints that we can use to conditionally render elements and switch CSS classes. I'll create a folder called hooks within which we'll create a file named useResponsive, which is also the name of our custom hook. Remember, hooks must begin with the word use. To build a hook that provides us with browser window breakpoints for the width, we'll first set up some default keywords and screen widths. I'm going to follow the screen size keywords and resolutions as used by a CSS framework called Tailwind CSS. What we're saying here is that our screen size is SM or small if the width is minimum 640 pixels and a maximum of 767 pixels, which is one less than the next breakpoint. Similarly, the screen size is MD or medium if the width of the window is a minimum of 768 pixels and a maximum of 1023 pixels, which is one less than the next breakpoint. In a similar fashion, we have defined a breakpoint for large and extra large screens as well. Anything smaller than the SM or small screen size would become extra small or XS. While this will serve as defaults, we will also let the user override these defaults by providing their own minimum screen widths. Next, we'll write a function that simply provides us with the current width of the browser window in pixels. This can be done by accessing window.innerWidth like so. Based on the width value in pixels and a supplied object like our default, which maps width to size keywords like SM, MD, LG, and XL, we'll write a function that provides us with the right keyword for a given screen width. This function simply uses a bunch of if-else conditions to return a suitable keyword based on the provided object. This brings us to our hook. So begin by creating a function named useResponsive. We will optionally accept an object named breakpoints, which can be used to override our default breakpoints. If the user does wish to override defaults, we'll merge that with our defaults like so. This means that you can optionally override one or more default breakpoints easily, and for the rest, it'll just use values from our defaults object. Now, a hook can use other hooks and can thus incorporate its own state and side effects, which it can then share with components. For this, let's import both useState and useEffect first. Now, as the page is resized or when the hook is instantiated for the first time, we will need a way to store the width value in pixels in a state variable. So let's create a variable named width along with its updater function setWidth like so. When this hook is instantiated, we'll need a way to set the value of this variable to the current width of the browser window. To do this, I'll set its default to a function which invokes getWidth, which is how we'll get the width of the browser window. Next, we'll create yet another state variable named size, which will store the active size keyword based on the mapped breakpoints. Once again, we need to set a default value here. We'll do this by invoking getSize in the initializer function, and we'll pass in the rules object so that any overrides may be taken into account, and we'll pass an invocation to getWidth so we get the active width as well. This will set the size variable to a keyword based on the width of the window when the hook is instantiated. But thereafter, if the browser window is resized, we need to actively compute and update these values. This means we need an event listener that keeps a check on the browser's window size. To instantiate this event listener, we'll use the useEffect hook. The first thing I'll do here is create a function that we'll use as the event handler for when the browser window is resized. This function will run every time the browser window is resized, and when that happens, we'll set our width and size properties again using the getWidth and getSize method like so. Now to run this function when the browser is resized, we'll attach an event listener to the window object for the resize event, and when this occurs, we'll invoke the resize handler function. Now since the event listener on the window object needs to be torn down when the component using the hooks is destroyed, we will use the return function here to remove the event listener like so. This, as you're aware, works a bit like component will unmount in class components and cleans up the side effect when the component re-renders or when it is unmounted. Lastly, we want to run this side effect only when our dependencies change. In this case, my dependency is the rules object, since this is a property from the scope of the hook function that our side effect uses to compute values. The useEffect hook requires you to explicitly declare properties, functions, and props that your side effect is using to compute values. For us, we are only using rules from the scope of the hook function, and we thus need to add it here in the array. The meat of our hook is now done. The last thing a hook needs is to provide access to methods or properties that the developers can use in their function components. In our case, we'll return the values of width and size like so. That's it. Our custom hook can now be shared with the world. Let's see how this can be used. Back in our app.js file, I'll bring in my newly created hook first. We'll then access the value of size by invoking this hook at the top level of our app component like so. Simple, right? This is all you need to interactively get the size of the browser window. If you need the values in pixels, you can also access the width property since we have exposed that too from our hook. For our container div, I'll use the array.includes method on the size value from the hook, and if it matches either sm or small or xs, which stands for extra small when the minimum width is less than 640 pixels of the sm breakpoint, then we'll overload the container CSS class with the vertical class, or else we'll use the bare container class which renders the horizontal version of the UI. Likewise, if the size keyword is either sm or xs, we'll render the phone login component. And it works. You can see our UI interactively switch as we modify the width of the browser window, all using a custom built hook. You can appreciate the simplicity here, especially how the hook is used in the app component. Developer experience is key when using hooks. Now, if you wish to override default breakpoints, you can simply pass an object that maps size keywords to screen width values in pixels of your choice, like so. You can see this in action as well. As you saw in this example, building hooks is amazingly simple. They are functions that begin with the word use and can incorporate their own state, logic, and side effects, which they are able to share with function components that use them. So go ahead and build your own amazing hook and share it with the rest of the world.